Adding and subtracting rational expressions is the 6-3B notes. They should go on page 76 of your notebook. There are several steps here. We do need to factor everything completely before we move on, but the most important thing we need to do is determine a least common denominator. That least common denominator needs to be made up of all of the pieces of all of the denominators for the problem. So in number 9, I have this denominator, and really I have a denominator here too. This is written as over 1, which is not going to make a huge difference, but we're going to write it anyway. So if I factor first, I notice that I can take something out of here. So each one of these is divisible by 2. So 2 is going to come out. This becomes x squared. This becomes minus 6x. And this becomes plus 8. And I still see a trinomial, which means that I should be able to factor by using magic numbers. So again, you can pause the video and you can try it out on your own, or you can do it in your head. So I notice that the first term is x squared. So x and x are going to be my first pieces here. I need to think of two numbers that multiply to give you 8, and they add to give you negative 6. 4 and 2 come to mind, so I'm going to write those down. And they need to have a negative sum, which means that both of them need to be negative. That way, when you multiply them back together, you're still going to get a positive answer. So that's my new denominator. So I'm going to go ahead and rewrite this. This is x minus 8 over 2 times x minus 4 times x minus 2. That's what this used to be. And then plus 2 over 1. Not very exciting. So my least common denominator is my next step. I need to come up with one of all the pieces of all the denominators. So a 1, but multiplying by 1 doesn't do anything, so I'm not really going to include that. A 2, an x minus 4, and an x minus 2. So these are all the pieces of the denominators. Step 3 is to multiply each rational expression, top and bottom, by whatever's missing to have that common denominator. Well, this is already the least common denominator, so I don't need to change this. But I do need to change this. This on the bottom needs to be my least common denominator, so I'm going to multiply by 2 and x minus 4 and x minus 2. And what I do on the bottom, I need to also do on the top. So now I'm allowed to combine these as one single fraction with the denominator that's the least common denominator, the LCD. But I need to add the numerators. So I've got x minus 8 plus 2 times 2 is 4 times x minus 4 times x minus 2, which actually we knew x minus 4 and x minus 2 together multiplied to give us this. So I'm going to go ahead and rewrite that because this step requires that I combine like terms. So I've got to multiply everything out. So I'm going to go ahead and distribute. This is x minus 8 plus 4x squared minus 24x plus 32, I'm sorry, I'm running into that line, over 2 times x minus 4 times x minus 2. There. And I do need to combine those like terms. So I see 4x squared, so there's my x squared term, negative 24x plus x, so that's minus 23x. I'm just combining like terms and crossing them out as I use them, so I don't reuse them. And then 32 minus 8, that would be negative 24. And my denominator is still 2 times x minus 4 times x minus 2. So now let's go ahead and flip to the back side. We've got one more practice problem like that, and then we move on to solving rational equations. Okay, so in number 10, First I want to factor, and then I want to come up with the least common denominator. The only thing that I can factor here is this. They're both divisible by 4. So I bring out a 4. What I'm left with is x minus 8. So what this has become is 4 over 4x minus 5 over 4 times x minus 8. So my least common denominator needs to include a little bit of everything. So it needs to include a 4, which both of them have. It needs to include an x, which only one of them has. And it needs to include an x minus 8, which only one of them has. So one of all the pieces. My next step is to multiply by whatever I need in order to get this least common denominator. So I have to have 4 times x minus 8. I have 4 times x, but I need times x minus 8 down here. So I'm going to multiply by x minus 8 on bottom and x minus 8 on top. Again, I need 4 times x minus 8. On this denominator, I have 4 times x minus 8. So I need an x in there. I'm going to multiply by x on the bottom and by x on the top. So now I'm allowed to rewrite this with a single common denominator of 4x times x minus 8. And I need to write the top. So 4 times x is 4x. 4 times negative 8 is negative 32. And then minus 5x. If I see like terms, then I should combine them. So I see I have 4x minus 5x. That's going to be a negative 1x. Still have my minus 32, and I still have my denominator of 4x times x minus 8. So I feel like these are probably the harder problems. As long as you can come up with the least common denominator and you can create the least common denominators in these problems, then you'll be fine. The very last section is solving rational equations. It goes on page 77. These are the 6-4 notes. And there's a video covering maybe half of the 6-4 notes. So you can go back and you can look at that. So when I'm solving rational equations, my first step in like all of the other problems is to factor. So I see that I can factor 4x plus 28, and whatever I get here is also going to be what I get for factors here, because it's the same denominator. So I can take out a 4. 4 comes out in front. This is x plus 28 divided by 4 is 7. That means this is also 4 times x plus 7. My next step is to create a least common denominator. Remember that it needs to have one of every piece of all the different denominators. This does not have a denominator right now, so I can put it over 1. So my LCD needs a 1, which really doesn't change anything here. It needs a 4, and it needs an x plus 7. There's nothing else in a denominator that needs to make an appearance in the least common denominator. So my next step, and I'm looking at my 6-4 notes, is to multiply every term on both sides of the equation by the least common denominator in order to cancel out all the fractions. And then once we simplify that, there shouldn't be any more fractions. So I'm going to rewrite this because I think that showing this factoring kind of gives us this extra layer of work, and I think that's confusing to look at. So this should be 7 over 4 times x plus 7. I'm just rewriting, folks. I'm not doing anything yet. Minus 2 over 1 equals 3 times 4 times x plus 7. Okay. Now I can do my step where I multiply everything times the least common denominator. So I'm going to multiply this term by 4 times x plus 7. I'm going to multiply this term by 4 times x plus 7. And I'm sorry I changed up the way that I wrote the multiplication. It means the same thing. And then I'm going to multiply this term by 4 times x plus 7. Anything that you can cancel out is a great way to simplify. So I've got 4's on top and bottom. They're gone. I have x plus 7's on top and bottom. They're gone. The only thing that remains is the 7 minus 2 times 4, which is 8, times x minus 7. We'll have to do, or sorry, plus 7. We'll have to do that distribution in a minute. Equal sign. I see a 4 on top and bottom. They're gone. An x plus 7 on top and bottom. They're gone. All that's left is the 3. Now I have kind of a simpler equation to solve. I do need to distribute this negative 8 to the x and to the 7. I need my x to be by itself. So I'm going to keep it over here, and I'm going to move these two things away. So I'm going to add 56 and add 56. 3 plus 56 is 59. I'm also going to move this constant over here, so I'm going to subtract 7, subtract 7. I have negative 8x equals 52. I'm going to divide by negative 8. If I simplify, 52 and 8 are both divisible by 4. They're divisible by 2, but they're also divisible by 4, and I'm going to get negative 13 over 2. If you divide it by 2 and then divide by 2 again, you should get the same thing. But I do need to check for extraneous solutions, so I need to make sure that nothing in my least common denominator is going to be 0 when I put this in. So I'm going to set each factor not equal to 0. So when I check, 4 is a factor, set 4 as not being equal to 0. Well, that's not a problem. 4 is not equal to 0. Then I set x plus 7 not equal to 0. Sorry. I don't want them to be 0 because I don't want denominators of 0, because that can't happen. So x cannot be negative 7, which is not a problem because x is not negative 7, it's negative 13 halves. So my solution is negative 13 over 2. And the last one, same steps. I need to factor if I can. So I notice that I can take out p's here. So p is left, plus 1. I've got a p plus 1 here, and then this was identical to this denominator, so this is also p times p plus 1. I'm going to go ahead and rewrite this kind of like I did this up here, because I don't want this double layer of work here. So I have 4 over p times p plus 1 equals 1 over p plus 1 minus 1 over p times p plus 1. Okay. My least common denominator needs to involve all the pieces from all the denominators. So they all have a p plus 1, so that's going to be in here. But 2 of them also have a p, so that needs to be there also. That's my least common denominator. I need to multiply all terms by the least common denominator. So times p plus 1 times p plus 1 times p plus 1. Cancel out anything that is common factors on the bottom and the top. So p and p cancel out. P plus 1 and p plus 1 cancel out. 4 remains equals. P plus 1 and p plus 1 cancel out. 1 times p remains minus. P and p cancel out. P plus 1 and p plus 1 cancel out. 1 remains. And if I add 1 to both sides, I get that p equals 5. I need to check to make sure that my least common denominator is not 0 whenever I use a p-value of 5. So let me move this up. So to check, I take each of my factors. So p, I set it not equal to 0. Well, that's not a problem because I didn't get p equals 0. That's fine. And then I set p plus 1 as not equal to 0. So p cannot be equal to negative 1, which is, again, not a problem because I said that p was 5. So the answer is p equals 5.